Good day from Chem Help ASAP. Let's tackle an SN1 reaction. As with all these sample problems, be ready to pause the video if you want to test yourself before I give the answer. Our reaction is on the screen. We have the starting material and reagents. Our job is to predict the final product of the reaction. Pause the video now if you want to try this on your own. I'll wait about 5 seconds. This reaction does not have a strong nucleophile or a strong base. Therefore, it can't be an SN2 or an E2. Furthermore, it doesn't even have a leaving group. It does, however, have a strong acid, sulfuric acid. The acid can protonate the alcohol in our starter material to form OH2+, which is a good leaving group. Note that when we do the protonation, we use protonated methanol as our acid. When sulfuric acid is mixed with methanol, methanol gets protonated by the strong acid, just like water gets protonated by strong acids to make hydronium ion. Okay, at least we will now have a good leaving group, OH2+. What will this leaving group do? We know it won't be an SN2 or an E2. The only thing left is to leave and form a carbocation. One word of caution. Before you think about forming a carbocation, you need to be sure it is either secondary, not great, or tertiary, still not great, but much better. For this reaction, we can form a tertiary carbocation. So the carbon-oxygen bond breaks, and we get a tertiary carbocation. Once you form a carbocation, there are two possible outcomes. Either an SN1, attack the carbocation, or an E1, remove the beta hydrogen. The SN1 is more common and occurs if you have any nucleophile present. Look at our reagents. We have methanol. The oxygen in methanol is not a strong nucleophile, but even a very weak nucleophile will attack a strongly electrophilic carbocation. The oxygen will attack to give this new charged species. We're not done because we need to get rid of the charge. We'll deprotonate the oxygen with our solvent, methanol. And that will give us our final SN1 product. This is an example of a solvolysis reaction. While we've drawn 4 distinct mechanistic steps: protonate, attack, leave, attack, and then deprotonate. From a reaction standpoint, this is just one step over the arrow. We just dump all the different chemicals together and the reaction will do the rest. In other words, we do not need to number separate steps over the arrow.